Welcome to Lesson 5. This is the lesson that makes this a project worth putting on your CV, so I am going to be slow and precise. First, let us take the word agent apart, because it sounds bigger than it is. An agent is a loop. You send the conversation to a model. If the model asks to call a function, you call it, you append the result to the conversation, and you go round again. If the model gives you a final answer instead, you stop. That is the entire mechanism. It is about 40 lines, and you are looking at all of them. So, if the loop is trivial, where does the quality come from? Two places: what the model is allowed to call, and what you asked it to do. Tools and brief. Let us do tools first. Open tools.py. Here is the most important function in the project, and it is 4 lines long. Run SQL. It takes a statement, it checks it, and it runs it. And here is the fence around it, which is 3 separate layers, because each one fails differently. Layer 1 is this connection, over in db.py. Mode equals read-only, passed as a URI. SQLite itself refuses to write through this connection. Telling a model to only read is a request. Opening the file read-only is a guarantee, and it holds no matter what the model decided to send. Layer 2 is this check. The statement has to start with select or with. And layer 3 is this one. One statement per call. Select 1, semicolon. Drop table orders is 2 statements, and stacking them like that is how SQL injection works everywhere else. So we block it here too. Now, layers 2 and 3 are not the guarantee. Layer 1 already was. They exist, so the model gets a useful refusal instead of an opaque one. And a model that understands why it was refused stops trying the same bad idea 5 times in a row. Now here is the part I got wrong the first time, and I am leaving it in the course because the mistake is worth more than the fix. In the first version of this project, there was only one tool, Run SQL. So when the agent needed to find which values were not numbers, it had to write that test itself in SQLite. And it wrote this: amount not GLOB, and then a pattern with a backslash in it. That looks correct. It is not. SQLite GLOB has no backslash escapes, so that pattern fails to match perfectly good numbers. The not inverts it, and all 678 rows come back as broken. And the agent reported that, with high confidence, because nothing it could see contradicted it. I did not fix that with a longer prompt. I fixed it with this: find uncastable values. It asks Python's float function, which is the actual definition of what will and will not convert. And it returns the distinct bad values with their counts, correct by construction and impossible to get subtly wrong. Then this second tool, bad value breakdown. You give it some columns, and for every combination of those columns, it returns how many rows there are, how many are bad, and the percentage. That is the move a data analyst actually makes. And doing the counting in Python means the model only has to read a table instead of holding a dozen numbers in its head. Here is the general lesson, and it is worth more than this project. Prompts steer. Tools decide. When a model has to invent fragile code to answer a question, that question deserves a tool. Now the brief in agent.py, read this line. The error message already names the column. That is not the answer, and repeating it is not a diagnosis. And then the steps. Look at the schema. Find the bad rows. Group them. Then narrow it, and this is the step people skip. The pattern has to be minimal. Take each column in it and drop it, and if the shorter pattern still selects only bad rows, that column was a coincidence, and it does not belong. A pattern with an incidental column in it sends somebody to go and fix the wrong system, and then check it in the other direction. Find rows that match part of the pattern, but not all of it, and confirm they are fine. That is the difference between a cause and a coincidence. Finally, the loop itself. Send the messages. If there are no tool calls, the model answered without finishing the job. So we say so, rather than treating prose as a diagnosis. Otherwise, we append the assistant turn exactly as it came back, run each tool, and append the result with its call ID so the model can match answers to questions. And when the model calls submit diagnosis, we take the arguments, write the report, and return. One last line, this one. Usage include true. OpenRouter tells you what the call actually cost, so the report carries a real number rather than an estimate of a price list that moved last week. In Lesson 6, we run the whole thing.